Example number 10. So find the area from 1 to infinity of x e to the x squared dx. So replace that with a limit. It's the upper bound, so we're using b. 1 b x e to the x squared dx. Okay. Now we need to do a u sub on this, so this is good, so our limit worked, but we need to do a u sub on this. So our u is going to be x squared, and then our du will be 2x dx. So we know we're going to have the x squared there because we picked that. The question is, do we have all the components for our du? We have the dx, we have the x. What we're missing is the 2 here, so we put that in, and then we have to balance it with a half. So now we have the 2, so we have our du. So this will be 1 to b, we have the 1/2, and then we have e to the u du. Now, because we've just did a u sub, these change, so this is really in terms of u. That's important because you don't want to plug in the wrong thing. And we still have this limit that's just going to sit here hanging around. Okay, so the u sub worked. Now we find the antiderivative. The antiderivative of e to the u du is e to the u. And we're ready to start plugging this in. So we have the half, and then limit as b goes to infinity of this whole result here. Okay, so let's change back to x. So limit as b goes to infinity of 1/2. Our u was x squared, so e to the x squared, and now we're evaluating from 1 to b again. So this is limit as b goes to infinity of 1/2 e to the b squared minus 1/2 e to the 1 squared. Okay, let's just clean that up a little bit. So that's going to be minus 1/2 e, and this is 1/2 e to the b squared. And now we need to evaluate the limit. So the b is only there. We're squaring it. Important to check the signs before you do anything else. So this is positive. This is positive. When you look at the original problem, it's positive. So that's good. We didn't make a sign error there. So this is going to be positive. So we're going to have e to the plus huge number, because when we take a huge number and square it, we still get a huge number. We have a half coefficient in front of it, minus a half e. So e to the huge number is even huger. Remember, you have some coefficient times it, minus a half e. Alright, so even huger means this blows up and becomes very big. So we have very big minus a constant, because that's all this is. So the end result for this is it diverges, because it keeps growing to plus infinity. So diverges.